Gravity is the ultimate sculptor of the universe. But what if I told you that our most famous cosmic masterpiece, the black hole, might actually be a mistake? For over a century, we have obsessed over these bottomless pits in space-time, places where gravity becomes so intense that laws of physics simply stop making sense. We have accepted the idea of a singularity, a point of infinite density, even though deep down, every physicist knows that infinite usually means we've done something wrong. But hiding in the complex equations of general relativity is a different kind of monster. One that doesn't lead to a dead end, but instead holds a bubble of exotic energy that could rewrite the history of the cosmos. They are called gravastars. These objects look like black holes, act like black holes, and have the same terrifying mass as black holes. But inside, they are something far more strange and arguably much more real. If you think you know the limits of gravity, prepare to have your reality shifted. To understand why gravastars are even a thing, we first need to look at the massive problem with black holes. According to Einstein's general relativity, when a massive star runs out of fuel, it collapses under its own weight. If the star is big enough, nothing can stop this collapse. It shrinks past its event horizon, and supposedly keeps shrinking until it becomes a singularity. This is a point with zero volume but infinite density. Here is the catch: nature hates infinities. Whenever an equation results in infinity, it usually signals that the theory has broken down and we need a new one. This is the central conflict of modern physics. General relativity describes the big stuff perfectly, and quantum mechanics describes the tiny stuff perfectly. But at the center of a black hole, they go to war. They refuse to play together. This is where the gravastar enters the chat. In the early 2000s, physicists Paul Mazur and Emil Mottola proposed a radical alternative. They asked, what if the collapse of a star doesn't end in a singularity? What if, as the matter reaches the threshold of becoming a black hole, it triggers a phase transition? Think of it like water turning into ice, but on a cosmic level. Instead of a hole in space, you get a shell of ultra-dense matter held up by a core of dark energy. The name gravastar is short for gravitational vacuum star. It is essentially a bubble of vacuum energy surrounded by a thin, indestructible crust. And the most mind-blowing part? From the outside, it would look almost identical to a black hole. Imagine you are a brave, or perhaps very foolish, astronaut approaching what you think is a black hole. As you get closer, you see the familiar warping of light, the accretion disk of glowing gas, and the pitch-black sphere in the center. But as you cross what should be the event horizon, you don't fall into a bottomless pit. Instead, you hit something. The gravastar doesn't have an event horizon in the traditional sense. It has a physical surface, a shell made of an exotic state of matter called a Bose-Einstein condensate. This shell is incredibly thin. We are talking about a thickness that might be measured in the width of a few atoms, but it is as hard as the laws of physics allow. Inside that shell, there is no crushed star. There is only a void filled with dark energy, pushing outward with enough force to stop gravity from winning the fight. This outward pressure is the key. In a black hole, gravity wins and crushes everything to a point. In a gravastar, the dark energy in the core acts like a cosmic spring. The gravity of the shell wants to crush the star, and the vacuum energy in the middle wants to blow it up. They lock together in a permanent stalemate. This solves the singularity problem instantly. There is no infinity. There is no point of zero volume. Everything is finite, measurable, and logically consistent. But just because it makes the math cleaner, doesn't mean it's less terrifying. If anything, a gravastar is a much more active and volatile monster than a silent black hole. Why do we call them monsters? Well, think about the energy involved. A black hole is like a drain in a sink. Once things go in, they are gone. But a gravastar is more like a pressurized tank. If that cage ever failed, the resulting explosion would be unlike anything we've ever seen. It would be a localized Big Bang. While black holes are messy eaters, gravastars are high-pressure storage units for the most powerful energy in the existence of space. Scientists are starting to look at our recent gravitational wave data with fresh eyes because of this. When we detected the ripples in spacetime from two black holes colliding, we assumed they merged into a bigger black hole. But some researchers are asking, did they? If two gravastars collided, the gravitational wave signal would be very similar, but it would have what physicists call echoes. After the main crash, the waves would bounce off the physical surfaces of the gravastars, creating a ringing sound in the data. We have already seen some strange signals in our current detections that look suspiciously like these echoes. If we confirm even one of these, The black hole as we know it is relegated to the history books, and the Gravastar becomes the new king of the dark. But let's go deeper into the guts of this thing. What is that shell actually made of? Mazur and Matola suggested that as the matter of a star is crushed toward the event horizon, it reaches a point where the particles can no longer be squeezed. Instead of collapsing further, they transform into a superfluid. This is matter that can flow with zero friction. It is so dense and so strange that it effectively becomes part of the vacuum itself. This shell is frozen in time due to the extreme gravitational time dilation. If you were standing on the surface of a Gravastar, millions of years would pass in the outside universe for every second you experienced. You would be standing on the edge of forever, watching the entire future of the cosmos play out like a fast-forwarded movie. And then there is the dark energy core. This is the same stuff that is currently making our universe expand at an accelerating rate. We don't really know what dark energy is, but we know it has negative pressure. Most matter attracts other matter. Dark energy repels it. By trapping this repulsive force inside a skin of gravity, a Gravastar becomes a sort of anti-star. It is an object that is only held together because its shell is strong enough to contain the force that wants to tear the universe apart. This makes Gravastars incredibly important for our understanding of the Big Bang. If dark energy can be concentrated like this, perhaps the entire universe started as a giant Gravastar that finally popped. This leads to a chilling thought about the fate of the universe. If the cosmos is littered with these bubbles of dark energy, they might be acting as anchors for the fabric of space. Some theories suggest that as the universe expands and galaxies get further apart, the Gravastars will eventually be all that is left. They will be the last bastions of matter in a cold, empty void. But because they have a physical surface, they can actually radiate energy in a way that black holes can't. They could be the final sunsets of a dying universe. But how do we prove they are real? In the world of space science, seeing is believing, or at least detecting is believing. The Event Horizon Telescope gave us that famous image of the orange ring around a dark center in M87. We all said, look, it's a black hole. But if you look closely at the physics of that image, a Gravastar could produce a nearly identical shadow. The only difference would be how light behaves right at the edge. A black hole has an event horizon that swallows light completely. A Gravastar has a photon sphere and a physical shell that might reflect or re-emit a tiny amount of that light. We are currently working on next-generation telescopes that will have the resolution to see if that central shadow is truly black or if there is a faint, solid structure hiding there. The search for Gravastars is more than just a hunt for a new object. It's a rescue mission for the laws of physics. If black holes with singularities exist, then information is lost forever when it falls in. This is the information paradox that Stephen Hawking made famous. If information is lost, the foundations of quantum mechanics crumble. But if the object is a Gravastar, the information isn't lost. It gets smeared across the surface of that incredibly dense shell. Gravastars save the principle of causality. They keep the universe logical. They allow us to believe that the past and the future are connected by a solid chain of events, rather than severed by a hole in reality. Wait, it gets even weirder. Some theorists have proposed nestars, nested Gravastars. Imagine a Gravastar inside a Gravastar, like a cosmic Russian doll. Each shell would represent a different layer of phase transition, trapping different levels of vacuum energy. If these exist, they would be the most complex structures in the universe. They wouldn't just be dead stars. They would be massive informational storage devices, almost like naturally occurring quantum computers the size of solar systems. For the space enthusiasts out there, this changes how we think about galactic evolution. We know that supermassive black holes sit at the center of almost every galaxy, including our own Milky Way. We call ours Sagittarius A star. We've always assumed it was a standard black hole. But what if it's a supermassive Gravastar? If it has a physical surface, it could interact with the surrounding stars and gas in ways we haven't modeled yet. It could be vibrating at frequencies that influence the orbits of the stars nearby. Some astronomers have noted that there are gaps in our understanding of how these central objects grow. Gravastars might bridge that gap because their surface allows them to accumulate mass differently than a hole that simply swallows everything. Let's talk about the look of a Gravastar. While black holes are famous for being invisible, a Gravastar might actually have a faint glow. This wouldn't be from gas falling in, but from the shell itself. Because the shell is a Bose-Einstein condensate, it could potentially exhibit quantum effects on a macroscopic scale. It might shimmer like a giant soap bubble, reflecting the light of the entire galaxy in a warped, beautiful display. If we ever managed to get a probe close enough to one, we wouldn't see a terrifying void. We would see a brilliant, metallic-looking sphere that distorts the stars behind it like a hall of mirrors. Because the shell is so thin and so dense, the gravity right at the surface is mind-bogglingly intense. If you stood on the surface, the difference in gravity between your head and your feet would be enough to stretch you out like a piece of spaghetti. The same spaghettification we talk about with black holes. But unlike a black hole, you wouldn't be stretched into a singularity. You would be crushed onto the surface, your atoms becoming part of that exotic superfluid shell. You would become immortalized as a layer of matter on the most stable structure in the universe. If an advanced civilization wanted to survive the end of the universe, where would they go? They would need a source of energy that lasts forever, and a place that is safe from the expansion of space. Some researchers have suggested that the surfaces of Gravastars, or the space just above them, could be the ultimate real estate. The extreme time dilation would allow a civilization to outlive the stars. They could build habitats that orbit just centimeters above the shell, fueled by the intense gravitational energy. To an outside observer, they would seem to be frozen in time, but to them, they would be living in a high-energy paradise while the rest of the universe fades away. But let's not get too far into science fiction. The real excitement is in the physics. The Gravastar model actually predicts how the universe's background radiation should behave. If there are enough of these objects, they should leave a scent in the cosmic microwave background, the light left over from the Big Bang. We are looking for these patterns right now. If we find them, it proves that the universe has a structure that black holes simply can't provide. It would mean that gravity isn't a one-way street to destruction, but a tool for creating new exotic forms of existence. Critics of the Gravastar theory argue that they are unstable. They say that if you throw too much matter onto the shell, it should eventually collapse into a black hole anyway. But proponents argue that the dark energy core is self-adjusting. As you add mass, the pressure inside increases, pushing back even harder. It's a dynamic, living system. This is what makes them so much more interesting than black holes. A black hole is a static solution to an equation. A Gravastar is a candidate for a real physical object that can respond to its environment. Think about the implications for space-time itself. If Gravastars are real, it means space is not just a stage where things happen. Space is a substance that can be stretched, compressed, and even frozen into a shell. It suggests that the vacuum of space is not empty. It is full of potential. A Gravastar is just a place where that potential has been realized. It is a bubble of true space held together by a skin of collapsed space. This moves physics closer to a unified theory, where matter, energy, and space are all just different phases of the same underlying thing. The monsters of space are often the things we don't understand. Black holes are monsters because they represent the end of our knowledge. Gravastars are monsters because they represent a new, overwhelming kind of knowledge. They suggest that the universe is much more crowded and much more complex than a series of holes in a sheet. They suggest that the dark centers of galaxies are not empty, but are occupied by spheres of exotic energy that have been sitting there since the dawn of time. If you're listening to this and feeling a bit of vertigo, you're not alone. The idea that everything we thought we knew about the most famous objects in space could be wrong is unsettling. But it's also the heartbeat of science. We thought the Earth was flat, then we thought it was the center of the universe. Then we thought the sun was the center. Every time we thought we had the final answer, the universe showed us something bigger and weirder. Gravastars are just the next step in that journey. They are the universe's way of saying you haven't seen anything yet. As we look forward to the next decade of space exploration, keep an eye on the word Gravastar. You're going to hear it more often. As our gravitational wave detectors get more sensitive and our telescopes get clearer, we are going to start seeing the skin on the dark. We are going to hear the echoes of the collisions. And when we finally confirm that there is no singularity, that there is no infinity, we will realize that we live in a universe that is much safer for the laws of physics, but much more crowded with strange, brilliant, and terrifying monsters. The black hole was a beautiful mystery, but the Gravastar is a physical reality we can actually get our heads around. It replaces a nothing with a something. And in a universe as vast and dark as ours, having something to study, even if it is a bubble of dark energy wrapped in a shell of frozen time, is a lot more exciting than staring into a hole that never ends. So forget black holes. The real stars of the show are the stars that shouldn't exist. The vacuum stars, the Gravastars. They are the true masters of gravity, the anchors of galaxies, and the potential keys to the past and future of everything we see. The next time you look at a photo of a galaxy, think about that tiny dark point in the center. Don't think of it as a drain where light goes to die. Think of it as a pressurized heart, a bubble of primal energy that is holding the whole thing together. It's not an ending, it's a state of being. The universe doesn't have holes, it just has We are just now learning how to read the first few pages. As we continue to peer into the dark, we have to be prepared to be wrong. We have to be prepared to find out that the monsters we feared were actually the builders of the world. Gravastars represent that shift in perspective. They are the bridge between the impossible and the possible. They turn the terrifying infinity into a tangible, if exotic, surface. Gravity might be a monster, but it's a monster with a structure, a shell, and a core. And that structure might just be the most important thing in the entire universe. Imagine the energy of 1 billion suns trapped in a bubble the size of our solar system, pulsing with the power of the vacuum. It doesn't want to swallow you, it just wants to exist in its perfect, frozen state. It is the ultimate expression of balance in a universe that often seems chaotic. Gravastars are the peace that follows the war of a star's collapse. They are the quiet, heavy giants that keep the galaxies spinning. And while they are still just a theory, they are a theory that is slowly but surely pushing the black hole out of the spotlight. So, stay curious about the dark. Don't be afraid of the monsters. They are just the parts of the universe we haven't met properly yet. Whether they are black holes or gravastars, they are the proof that we live in a reality that is far more imaginative than we are. We are looking for the next monster to teach us a new lesson about the stars. And the Gravistar is ready for its close-up. In the grand scheme of the cosmos, we are just beginning to understand the heavy hitters. We've named them, we've photographed their shadows, and now we are starting to peek inside. The transition from black hole to Gravistar is the transition from mystery to physics. It's the moment we stop saying we don't know and start saying this is how it works. And that journey is the greatest adventure humanity has ever embarked on. Gravastars might be the real monsters of space, but they are our monsters. They are part of our story. They are the fingerprints of gravity on the fabric of the vacuum. And as we learn more about them, we learn more about ourselves, about our ability to comprehend the incomprehensible, and our drive to find logic in the dark. The universe is a big, strange place, and Gravastars are just one more reason to be amazed by it every single day. So the next time you hear someone talking about black holes, maybe drop the word Gravistar into the conversation. Tell them about the bubble of dark energy. Tell them about the shell of frozen time. Tell them about the echoes in the gravitational waves. Because the more we talk about these things, the closer we get to the truth. And the truth, as always in space, is much more terrifying and much more beautiful than anything we could have dreamed up. The monsters are out there, but they aren't hiding. They are standing right in the center of the light, waiting for us to see them for what they truly are. Not holes, but stars. Not endings, but beginnings. Not black holes, but gravastars. The real sovereigns of the abyss. The real heavyweights of the night. And the real future of our understanding of the universe. Gravity is calling, and the answer is written on the surface of a star made of nothing but space itself. As the years pass and our technology improves, the debate between black holes and gravastars will likely be one of the most exciting battles in the history of astronomy. It's a battle between the old guard of singularities and the new guard of phase transitions. And no matter who wins, we are the ones who get to watch the discovery happen. We are the ones who get to live in the time when the monsters finally got their names. So keep looking up, keep asking what if, and keep wondering about the dark. The universe is full of surprises, and the Gravistar might just be the biggest one of all. It's a star that isn't a star, in a hole that isn't a hole, creating a reality that is far more solid than we ever imagined. The monsters are real, and they are magnificent. Welcome to the era of the Gravistar. The universe just got a whole lot more interesting.